Good morning everyone. Today I am hereby to give a presentation on classifications and characteristics of expansion wave. So before discussing about before getting into topic, I would like to give a timeline in which we are going to discuss in this session. In the initial stage, I supposed to give a small introduction myself, and then follow on discuss the abstract, introduction, expansion wave, and conclusion. Introduction. I will give a small introduction myself. My name is Hsad, having a pin number of 219552109, and my topic is expansion wave, and this topic is belongs to a course name called ICP aerodynamics. Next, abstract. In this presentation, we discuss expansion wave, its characteristics and classification. So let's begin the session. Introduction. Expansion wave. A simple wave or progressive disturbance in the isotropic flow of a compressible fluid such that the pressure and the density of a fluid particularly decrease on crossing the wave in the direction of its motion. This may be illustrated, for example, by the withdrawal of a piston from a gas-filled cylinder when the gas is initially at rest in the cylinder. An expansion wave may move into the undisturbed fluid at a speed of sound as the piston is withdrawn, and the expansion wave is a finite amplitude disturbance changing shape as it propagates, but it may or may not be accomplished by a shock wave front with the associated discontinuity. See completion wave. Now let us discuss about the expansion wave. Now let us discuss the characteristics of expansion wave along with the classification. Classification and characteristics of expansion wave. The oblique shocks or compression waves in the supersonic flow that abruptly stun the flow and compress the gas in the process. An expansion wave causes a supersonic flow to turn and the static pressure to drop. The expansion waves are Mach waves that make a Mach angle with respect to a local flow. The flow through expansion wave is inherently isotropic, as the Mach waves are of infinitesimal strength and hence reversibly. An expansive Mach wave is capable of only turning the flow incrementally and accelerate the flow incrementally. Such a flow turning and flow acceleration is shown in figure 1 with the acceleration of the turning angle and the flow acceleration increment. The local wave angle with respect to upstream flow is at the Mach angle mu. The incremental turning angle is labeled as du. The change of velocity is shown by the magnitude of dv and the direction d theta with respect to upstream flow. Since the velocity downstream of the Mach wave has the same substantial tangential component as the upstream flow, the right triangle that share the same tangential velocity are labeled with v and v plus dv vectors shown in figure 1. Expansion wave. In this figure we can able to see the expansion wave. So in this we can able to understand initially a wave is started at the position with a v and the angle of a mu, and then it's supposed to move, and we can able to see the end products. The end velocity is treated as v and w, and we can see here we can able to get the v plus dv, and here we can able to get pi by 2 by mu, and here the angle is supposed to be pi by 2 by mu minus dv, because as you know that the sum of the angles in triangle is must be possessed to 180. So in this, if we observe here, we can able to understand why we get pi by 2 by mu, because sum of angles 180. Here we can able to understand, here we get come across the d theta, and for example if the angle and it is a straight line, as you know the sum of the angles is 180. So as for they mention that this angle is belongs to easy, this angle belongs to this, as therefore the remaining angle is also, therefore this angle is also same as this, because sum of the angle is subject to 180. Then next hang on a minute. Uh, so next, now we will discuss about the in again now, because we had we had we had not understand, we had not discussed about the main point in this classification, that is this is the figure, this is the figure one. So in this content we can able to see, uh, in there they mentioned that the figure one, they mentioned the figure one. So let us again discuss about this classification, the oblique shocks of compressive waves. So in which it will discuss about the oblique shocks are generally compressive waves, in which it is causing supersonic flow, in which it is capable to turn the flow and then compress the gas in process. And the expansion wave, which causes the supersonic flow in turn, as tends to drop the static pressure. And the expansion wave or Mach number, the Mach angle with respect to the local flow. The flow through expansion wave is inherently isentropic, as the Mach wave of incremental size, strength and hence reversible. An expansion Mach wave is capable of only turning the flow incremental and accelerates the flow incrementally. Such a flow turning and flow accelerating is shown in figure 1 with a exaggeration of the turning angle and the flow acceleration increment the local wave angle with respect to upstream flow is at the Mach angle mu. The incremental turning angle is labeled as dv. The change of velocity is shown by the magnitude of dv and the direction d mu with respect to the upstream flow. Since the velocity downstream of the Mach wave has to have the same tangential component as the upstream flow, the right triangles that share the same tangential velocities are labeled with v and v plus. So in this figure, you can able to understand, again this question. This is the component of v in which it is supposed is passing with the velocity, and then if we observe, this angle is theta as in mu, and then here we suppose this angle is as d theta, and this angle is known as this angle, and next this angle is known as this angle. In order to get, hang on a minute, I will clean the screen. In order to get this angle, as you know that the sum of the angles is subjected to the 180. So as you know that, so in order to get this angle, we will say as 180 minus d theta minus, and as we know that here it is a straight line in which the angle of a straight line is supposed to be always 180. So therefore, as per the given data, this angle is 180. So therefore this angle will be 180 minus pi by 2 minus mu. By substituting the value here, we get 180 cancel, and we get pi by 2 minus mu. Hang on a minute, I will clean the screen. So we will get this as pi by 2 minus mu minus d theta. That's it. This is important. Next, now conclusion. An expansion wave causes a supersonic flow to turn and static pressure to drop. The expansion wave or Mach waves that make a Mach angle with respect to a local flow. The flow through expansion wave is inherently isentropic, as the Mach waves are of infinite strength and hence reversible. Thank you.